Welcome to the podcast. This is Mr. White.
Mr. Johnson.
And today we're talking about your investigation where we related pitch to frequency. And so this is probably my favorite chapter to teach.
Mm-hmm.
I don't have a musical bone in my body, but I find it all very fascinating. And so while I don't really know how to play a musical instrument, and I certainly don't sing, at least not as for others to hear, which term did you hear in your music class when you were a student? Did you hear about pitch or did you hear about frequency in music class?
I heard more about pitch.
Yeah. And so pitch is a perception. So this is like, this is what your ear detects. So like I know musicians that can pluck a couple strings on the guitar and they can tell you that string is flat and that one's sharp, and they twist out on the screw or the machine head one way or the other, and they tune it by ear. Their ear hears pitch very well, and the perception of sound is really good. So is a perception of sound. It's nice.
I don't have that ear.
No. Had my piano tuned. Guy tuned the entire piano, all 88 keys, by ear.
Wow.
With a tuning fork. So he'd hit the tuning fork. He'd bring the tuning fork up to his ear. He'd hit the note on the piano, and he could tell how close they needed to be, and he'd either tighten or loosen the string, hit the tuning fork again, hit the key, boom, boom, boom. In an hour, he did all 88 keys. It was unbelievable. And that's all about pitch and perception. Frequency is a measurement of sound. So the frequency side, so this we would say more is music class. This is more science class. This is more the human ear. This is more some sort of scientific instrument, which they do exist. We do have some of this equipment in the building.
Mm-hmm.
The music department actually has a tuner that they use both in band and orchestra to tune correctly. So pitch versus frequency, just wanted to get those two ideas out of the way. Of course, what happens is you guys did this experiment where you hung a weight, okay, over like this cup. And so everything kind of sat on a table, right? It's the worst drawing ever, perhaps.
I was going to say, it looks like you've been practicing.
Oh, that's good. So this weight put some tension in this string, and we would move this cup around, and this acted as two things. This acted like the body of a guitar, which is important so that the sound reflects inside of it and is propagated out. And this also acted as a fret. What is a fret, Mr. Johnson?
Isn't that the neck of the guitar?
On the neck of the guitar, it's like a cheat sheet. There's these little nubs.
Mm-hmm.
And the guitarist actually feels them and knows where to push down the string to play a certain note. So the string would hit the cup so that the sound would bounce around and reflect out, propagate. And it changed the length. So if we plucked the string with a certain tension, we would get a sound. I'm not going to call it a note, but we would get a sound as a result of this. So by plucking the string, okay, the string vibrates. Why is that important?
Well, the vibration is what actually creates a wave in which the wave enters your ear and you translate to make sound.
Yeah, specifically the vibration causes the sound wave. And if the string doesn't vibrate, there is no sound wave. There's nothing to hear. So that's really important. So strings do this very well. And that's why strings are used in a whole host of musical instruments. Let's see. Guitars, cello,
Harp,
yeah,
violin,
viola,
banjo, ukulele.
There you go. Now, piano is a tricky one. Is piano a stringed instrument, or is it a percussion instrument? Because a piano,
well,
it has a hammer. You hit the key,
yeah.
The hammer hits the string. And I've heard it argued both ways. So,
Well, there's legitimate arguments for both ways.
Right.
Because, I mean, realistically, you you're just striking a key with the hammer hitting the string. And no matter how hard you strike that key, the hammer only hits it a certain.
There's a maximum amount that
Right.
you can hit it. That's correct.
So you really can't change like a drum. I mean, you could bang on that thing and make it really loud.
And that's interesting that you mentioned a drum. A percussion instrument, a drum, a xylophone, a marimba, some of those instruments, they act just like a string. What you can't see is that drum skin, or that they call it a key that sits on top of that xylophone, vibrates. And the vibration is so hard to detect with your eyes, the only thing you can detect with is your ears. So that piece of metal or wood vibrates just like that string does. So that's the basics of what we did here. We changed two things today. We changed the tension, and I suppose I probably wrote that in the wrong place. The tension is varied by adding more weight or less weight, and then the length is changed by moving the cup around. So just some basic relationships. Let's review some things. So we did a whole bunch of things. So if we kept length constant and we increased the tension, so we put more weight on it, what did that do to the frequency?
Well, I think that would increase it because the more tension, it would actually vibrate a lot faster, making the frequency go up.
That is correct. And so if the frequency went up, hey, so did the pitch. If we decreased the tension, what happened to our frequency?
Well, it goes down.
It went down. And our pitch would also go down. There's a lot of things now we can write about this. We can say frequency and pitch are directly related. Can't we?
Mm-hmm.
What else can we say? How can we include tension into this? Up, 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 down, down, down.
Well, the greater the tension, the greater the frequency.
So, tension and frequency, therefore pitch, are directly related. There we go. So, on a guitar, for example, if you were to tighten the string by turning the screw or the machine head, tightening it, pulling that string tighter, would cause a higher pitched sound.
Right.
Keeping it loose would produce a lower sound. Okay. What if we kept the tension constant? By the way, this is what you do in a guitar. You set the tension and you play at that tension of the string. So we can either increase or decrease the length, and of course that will affect the frequency, and of course that will affect the pitch. So, longer strings. Increasing the length of the string does what to the frequency?
I would probably say it lowers it.
It does lower it. It makes a lower note, and it decreases the pitch. Okay? If you make a shorter string, you decrease the length of the string, the frequency would then
Increase.
go up, and the pitch would go up. We already know that frequency and pitch are directly related from the last slide. But length and frequency, therefore pitch, are what?
It would be, well, opposite would be inversely proportional.
Inversely related or
Or
inversely proportional, yeah. Interesting. And we know this because if we don't push down on the string, on the fret, on the neck of the guitar, we play a note. We don't know if it's high or low. If we cut that string in half, or we push down halfway up, we get a higher note by decreasing the length. So longer strings do in fact lead to lower notes.
So that's why when guitarists want to hit that real high-pitched note, their hands are almost all the way down on the guitar.
They're right on the body of the guitar. That's correct. So there's a lot of stuff that goes on there, and these relationships, by the way, they not only relate to the guitar, they relate to all the other stringed instruments that we mentioned. They also relate to wind instruments. The longest wind pipes, and a musical instrument play the lowest, deepest notes, and the shortest pipes play the highest notes.
So like comparing a kazoo and
Short,
that horn on the Ricola commercials,
long.
that's why it's real deep.
That's it. So the ideas are all connected, which I always. It's nice to know that the rules of physics are the rules of physics. We don't have special rules for the guitar and new rules for the clarinet.
Do you think we ruined music for some of these kids?
I certainly hope so. And actually, at the end of the unit,
Right.
We do the whole Blue Man show down in the auditorium, and we talk about this and answer questions, and we see what those guys did. They applied some science to their music. So, yeah, it can ruin it, but it can also enlighten you in a lot of ways.
And plus, it's going to help you with your chapter challenge because now, if you decide to make a guitar or a stringed instrument, you know that the length affects the different sounds. So if you're going for a certain sound, you just apply what you learned here.
Absolutely. So I believe that covers section 1.
Okay.
Signing off. This is Mr. White.
Mr. Johnson.